Hello students. So in today's video we'll be doing one quick start on PyTorch. So hopefully after watching this video you will be able to code in PyTorch, the framework for popular deep learning neural networks and all. So after this video, if you have gone through this video carefully, you will be able to at least code in PyTorch framework, I guess, and you can build the simplest neural network. And along with this, you will also understand the basics of neural networks and tensors, right? So the learning objectives will be understanding how to manage, scale, and normalize your data set using CPUs and GPUs in PyTorch. Then build an image recognition model, which is the very basic of any deep learning neural networks using neural network that we're going to build with the help of PyTorch as a backend, and uh, how to optimize your models using PyTorch that we'll see, and how to enhance your models with for inference performance, right? That also we'll see. And basically after this tutorial or quick start, you will be able to code in PyTorch. Okay, so first thing that as we are dealing with this recognition model, right? So cat versus dog or whatever, probably we are going to deal with fashion MNIST. So one thing will be required, very basic understanding of your computer visions images, and foremost the first thing that you will have to understand the tensors. Okay, because internally in whether it's PyTorch or TensorFlow or any deep neural network applications, right, most of the frameworks or models, they expect tensor as an input and tensor as an output. Okay, so what are these tensors? That is basically we are going to see, right? So this is very basic stuff you already know, so I'm just ignoring all of this. So just quickly come here, images as tensors, right? So normally if you go and see MNIST data set, right? So if you come to this data sets page and if you search for MNIST, right, you will find fashion MNIST, I guess, here somewhere. Yeah, this one. So if you come to this data set, you will see all the details about this data set. So mostly it's nothing but some fashion related products and their images and their labels, right? There's 10 product categories available, and you will have each images as 28 cross 28 pixel in grayscale. So these are not RGB images, which typically has three channels of red, green, and blue. So these are grayscale images, that means white and black, pixel range from 0 to 255 in normal scale, and in normalized scale from 0 to 1. Okay, so what you will have the width and the height of the images as pixels, and you will have 28 cross 28 28 cross 28 matrix kind of formation, and based on that matrix you will have the intensities as integers. Okay, so this is the overall view of your image that you will see. Okay, the next thing, one more like addition to this image is the, if you want to configure the videos, okay, so that is also possible from these images. What you will have to do, you have to add the frames. So let's say you are capturing 200 frames of a video segment, right? Then the size of your tensor will become 200 times 3 times 600 times 800, provided you have a, let's say, RGB, that means color video of 600 times 800 dimension. Okay, so this is basic of your images representation as tensors. So why we require tensors? Because of this use case, right? So tensors means nothing but multi-dimensional arrays. So we can store all the details numerically as a multi-dimensional arrays, and it is pretty much easier, and at the time of computation you can use GPUs for parallel computation. So that is also another point. for which tensors we are going to use instead of numpy arrays and all for most of your deep learning framework tasks. Okay, so first thing, as we are dealing with PyTorch, right? So we'll import torch. As we are dealing with some image classification problem, that means a computer vision problem. So we'll import torch vision, and for printing out all the images that we will be dealing in this fashion MNIST dataset, we will be requiring matplotlib, and numpy will be requiring for numerical processing. So let's just load this for quickly. So two things here, right? One is MNIST and one is fashion MNIST. So if you are trying this tutorial with fashion MNIST, then I will suggest that you will do yourself the MNIST dataset as an exercise. And if you are trying let's say MNIST with this tutorial, then I'll suggest or encourage you to work along with fashion MNIST as an exercise. Okay, so we, I guess, got our runtime connected with Google Colab with their servers. Yep, so you can see we have got one TPU allocated for us, and this cell we have completed. So the first thing, what are tensors? So as you have seen here, tensors are specialized data structure that are very similar to arrays or metrics in PyTorch. We use tensors to encode inputs and outputs of a model. We have already spoken about all of this, right? As well as all other parameters. Okay, so if the numpy arrays are similar to tensors, okay, then what is the difference between I mean numpy and tensor, or why we have to use probably tensors instead of numpy? The very simple approach is you can think about to use GPUs, as GPUs have more cores compared to CPUs, and tensors allows doing parallel computation across this GPU cores. So to utilize that, to quickly finish the training and all or computation, as you already know that deep learning is very computational expensive methods basically. So to solve all of that, we use tensors instead of numpy arrays. Rather than it's similar, even numpy arrays and tensors, as you can see here, they share same memory address internally. So you can call tensors from you can interchange between tensor and numpy arrays. We will see that later in this tutorial notebook, this thing. Okay, and if you want to know a little bit more about tensors, 2 or 3 lines extra, you can definitely go to this discussion that has a very straightforward layman answering of what's tensor and why there is a difference between tensor and numpy. Okay, so again, let's just import the required stuffs. So we have already imported all of this to here, right? No need, but okay, it's the boilerplate codes. So first thing, as it's a very starting of your PyTorch journey, so brushing up your very basic PyTorch skills will be must required before jumping into the this MNIST dataset codes. So here you can see we have a data in some matrix, or you can say multi-dimensional array format. So if you do one commenting out this code here, and if you run this, so what it will do, it will load the data. Right now if you just print, okay, the type of the data, you will see it's a list, it's a Python data structure. Right now again you bring back this code here, so you have a list, and you call this torch.tensor method, and within the tensor method you are passing a Python list, and then you are calling, then you will see that your list got converted into a tensor. Okay, so tensor is a different data structure and list is a different data structure. Okay, so this is the very basic initialization of tensors inside your PyTorch framework. So once that is done, we'll quickly move on to your NumPy arrays, how you can define a NumPy array and how you can convert between PyTorch and NumPy arrays. So the first thing, we have already imported NumPy as NP, right? So np.array is the method, and in that array method, if you give any, multi-dimensional arrays, or basically it's nothing but list in Python data structure. So if you pass any list with multi dimensions, it will create a NumPy array, and once that NumPy array is created, you can create a tensor from this NumPy array by using this from NumPy method. So previously we created tensors, right, using this tensor method. Now we are using from NumPy method to create tensors from NumPy array. So once this two is created, these are some printing statement that we are showing that this NumPy array and tensor created from NumPy array shares same memory structures or memory addresses basically. So if you can see here, this NP array and that we are printing at the very first is our data, right? So our data is nothing but this 234533, right? So that's got printed, and this is the tensor value again in the next line. So it is also nothing but the same NumPy array we just passed, right? So you can see here, this is the tensor and this is the NumPy array. And now what we are doing, you are using one method called multiply, and we are passing this NumPy array and 2, so it will do element wise multiplication, and we are storing this output in the same NumPy array, right? So ideally what will happen, this NumPy array got converted into another NumPy array where each element is 2 times the previous one. Okay, so once that is done, you can see the output here, and when again you will call this tensor, so the tensor will also reference the same NumPy array, so it will also have the same values, right? So it will not have the older values, this 2 3 4 5 3 3, it will have the newer modified values, right? This 4 6 8 10 and 6 6. So why this happens? Because as we have mentioned one property of NumPy arrays and tensors, right, that tensors and NumPy arrays can often share the same underlying memory address with a capability called bridge to NP level, right, which eliminates the need to copy data, right? So this is one important point that you need to remember when you will going for an interview or probably your day-to-day task, right? When you are dealing with NumPy array and tensors. So two things till now we have covered, right? From NumPy array and from normal data. The third one is from tensors, how you can create it. So like any other language or framework, right? Let's say TensorFlow, where you can use similar kind of like approach to create tensors with all the ones and zeros. That is also possible in PyTorch. So torch.onesLike, and you have to pass the shape of the tensor. So here we are passing the shape as this data tensor, right, that we have created. So this data tensor that previously we have created, right, so this shape of this tensor will get carried forward to here, and all the values will get replaced by ones, and here same thing will happen. Besides, all the values will get replaced by random values, right? So if you run it, you will see the same thing. So what it is doing, it retains the property of x data, right? X data means your first data, I guess. Yeah, this one. Okay. Now next one is with random or constant values, that is also possible. So torch dot, previously we have used this ones like method. So if you use ones or zeros or random and you pass a shape, right, then what will happen, it will use that shape and it will populate that shape with values, any random values or one value or zero value, right? So we can quickly verify and move. You again increase the shape from 2 dimensional to 3 dimension, and you can see similar kind of tensors get generated. So this shape is very much important while you deal with deep learning networks, because mostly whatever errors you will see later point of time, you will see you are facing this that kind of error because of this shape only. Okay, so now moving forward, attributes of a tensor. So these tensors will typically have three required attributes. One is its shape, second one its data type, and third one is the device, in which device this tensor is stored. So here you can see it is stored on CPU. Okay, the data type is float and the size is 3 comma 4. Okay, so it's a two-dimensional tensor, you can see. Okay, now operations on tensors. So there are more than 100 tensor operations, including arithmetic, linear algebra, matrix multiplication. For sampling and reviewing, you will find all a comprehensive description in this link. So I'm not going, probably this is the link, right? So all this tensor operations are available, so you can see all the required things right here, all the required stuff. So probably in your career or in your lifespan you don't require all of this, but yeah, it's good to have the documentation along with you. The next one is like each of these operations can be run on GPU at typically higher speed than on a CPU, which you already know. And why? Because CPUs have to up to 16 cores units that do the actual computation inside your processor or computer. Basically, each core processes task in a sequential order, whether your GPU operates on a parallel way. Okay, so GPUs have thousands of cores. GPU cores handle computation in parallel processing. Tasks are divided and processed across the different cores. That's what makes GPU faster than CPU in most cases. So when you play some high what graphics video game, and that games are very fast in GPU processor rather than your CPU computers. This is the reason, and because of this gaming and all, right, this GPU what this GPU revolution happened, and from that this deep learning picks up. Okay, deep learning was there in 1980s and 70s also, but that time due to lack of infrastructure, research couldn't take place in the speed I mean the way it is right now. Okay, now GPUs perform better with large data than small data. This is another point you have to always remember, that if you have very small amount of data, GPU or deep learning may not perform very well on your data. GPUs are typically used for high intensive computation of graphics on neural network. Okay, so PyTorch can use NVIDIA CUDA library to take advantage of their GPU cards. That's it for basic of your tensor and PyTorch initials that you have to remember, right? So how this code will let you know that okay, torch.cuda is available. So from this method you'll know it will be a binary. If the return is true, what you can do, then your tensor, you can transfer your tensor from CPU to CUDA. Okay, so and then again you can check, but in as we are connected with this TPU, right? So let me see if we can change the runtime, right? So in real time, if we can change runtime type, so let me see, there is a T4 GPU available. I don't know what is this T4 GPU means in Google Colab. So let me, okay, sorry, I guess something wrong. Okay, now I guess we are connected to GPU. So let's see if it's a CUDA GPU or not. Okay, okay, we again have to run because the runtime got disconnected, right? So quickly just run all of this. All the imports are done. We have to do all of this or else in later point of code you will face error, and again you have to come back here. It's better to run everything once. So yeah, if it's a CUDA GPU, then it should pick up and it should show that the tensor in CPU rather than your GPU. So now see this tensor dot device, so it's still a CPU, so probably this T4 GPU is not a NVIDIA CUDA GPU. Okay, no worries, we're not doing very hard computation here, so CPU will be enough and Google Colab will be enough for performing all the steps in this notebook. So yeah, again, to understand the shapes, so let's say torch dot once will and passing the shape here, two-dimension shape of 4 by 4 will create a matrix of 4 by 4, right, this tensor. So if you just pause all of this and print the tensor only, you will see a tensor that basically it's a matrix of 4 by 4, right? Now what your first row should return, your first row should return this one. Your first column should return this one, this first four, this one. Then your last column should return this one, right? And in this step you are making the first column, that means sorry, one index, that means your second column, right? Your second column, this one, to 0. So when you print this tensor finally, you should see 1 0 1 1 1 0 1 1 1 0 1 1 1 0 1, right? Very simple to understand all of these codes so far, I guess. So I'm just running all the steps at once for you, so you can see your first row got printed, first column got printed, last column got printed, and your tensor, as we have expected, got printed, right? So till so far I guess everyone is clear with the codes and understanding of basic of tensors basically without any hesitation. Now next is a join operation, so concatenation. Likewise you have in SQL, Python, here in sklearn, or in your what TensorFlow, so in any other languages, right? So there you will have a cat method that will concatenate the tensors basically along with the dimensions you will provide. So dimension 1 means along in case of 2 dimension along your columnar side, and dimension 0 in case of 2 dimensional tensor along row side, it will concatenate. So here the 3 tensors it asks to concatenate along the column side. So you can see this is your first tensor up to this one, up to this one, then this is your second one, this one is your second one, then this one is your third one, and they got concatenated along the column wise. So you will see an increase in your column number, right? If this is a SQL table, then you will have 12 columns, and similarly if it's basically SQL, then same thing, in this portion you will have 12 rows, right? So dimension 0 means your x-axis, dimension 1 means your y-axis. In case of your structured data, that means your two-dimensional array or two-dimensional data, right? In case of multi-dimension, it will be configured on this axis based, right? 0 1 2 whatever. Now next process is basically stacking. So why we require stacking? Similar to concatenation, if you want to maintain the dimensionality or the shape of the tensors, then we use this stacking approach. So torch dot cat in that case, and in this case torch dot stack, and you will pass all the tensors and you will pass the dimensions similar to that, and you will get your stack tensors, right? So in cases where you require, knows the exact shape of your tensor output, you can use this stack method along with the dimension where you need to stack all of these tensors, and you will have your output, right? So similar to this one, if you stack along dimension 1, you will find this tensor, right? So here what is happening, you are stacking along the rows, and here what is happening, you are stacking along the columns, right, based on dimension 1 and dimension 0. right? So similarly, same thing here also, it is showing, but with negative indices. That is also possible because if you know that Python supports negative indices, right? Now this is pretty straightforward. It's only, knowledge purpose, that this at the rate indicator means a matrix multiplication. That means that basically your tensor to tensor complex matrix multiplication will be performed, and you know that for matrix multiplication your shape is very much important, right? So here the shape is 4 times 4, uh, and then you will have another 4 times 4, right? So your output will be also 4 by 4. Here in Python, right? So in Python, I guess, okay, I forgot. This is how you write statements in Python, right? Then second one, the same thing you can also achieve using a function called matmul. So this matmul will utilize this tensor module, and again it will provide you the same output as expected here. Okay, and this operation is particularly your element by element multiplication. So this is the two difference. So this matmul is your matrix multiplication, and this mul is your element by element multiplication. So this code cell provides all the details, so you can go through and run all of this, and that's it. And the final one here is your single element tensors. So let's say you have a tensor and you have performed one aggregation, summation, mean, max, median, whatever, right? And you have the result, and you want to utilize that result basically as let's say integer to one condition or whatever business logic that requires. So you can call this dot item. This dot item method, what it will do, it will return the numerical value of the required tensor, right? So here if you run this, you will see a 12, and you will see it as a float instead of tensor, right? So if you only print let's say along all of this, you print this aggregation, so you will see it's not 12 float, it's a tensor that contains this 12. Okay, the next one is in place operation. That means doing some manipulation inside the memory. So for that you will have to use this uh, additional underscore after the method. So let's say subtract, minus, multiply, add. So add, then another underscore, and then you give the let's say I want to add 5 with the tensor, then it will do the same, and it will do that in memory. In memory means within the same memory address of the variable. Normally what how we used to write is to write tensor 1 equals to, right, this tensor plus 5 and all. So if you want to eliminate that and you want to calculate inside memory some operation, you can utilize these methods, and that's it. So I guess, and one final thing I guess we have here before we wrap up this basic operations along with PyTorch is NumPy and tensor. Okay, so what's this NumPy and what's this tensor conversion? We have already seen before there, right? Also, so this dot NumPy method will convert your tensors into a NumPy array, and from NumPy method will convert your NumPy arrays to tensors. Okay, so that's it for the first video. I hope you have learned the very basics of your tensors and how to do some basic operations, arithmetic operations basically, and matrix operations utilizing your PyTorch library and all the operations provided by it. In the next video, we'll start and we'll see the very basic deep learning neural network, how to implement using PyTorch. Thank you.